Good day, myself S. Periyar Selvam, working as Associate Professor in the Department of Food Process Engineering, SRM Institute of Science and Technology. Welcome to the Department of Food Process Engineering YouTube channel. In the current session, I will brief about the importance of water activity in food for the growth of microorganisms. Factors affecting the microbial growth are classified majorly into two types. One is internal factor, another one is external factors. In the internal factors, it's going to be covered pH, hydrogen ion concentration, and second one moisture, water activity or available water of food, oxidation reduction potential of food, and nutritional and types of nutritional like a protein food, carbohydrate food, and lipid foods. An inhibitory substance, that is antimicrobial substance present on the food material, it going to be influence the growth of microorganisms. And also the structure of the food, it is going to be influence the growth of microorganism, that is a barrier properties. And the external factor, it is going to be covered the storage temperature, storage humidity, storage gas compositions, and microbial activity. Why we want to know the factors affecting the microbial growth? The knowledge is going to be provide the understanding of principles of food spoilage and preservation. Water activity defined as vapor pressure of food substrate divided by vapor pressure of pure water at the same temperature. Water activity related to relative humidity as relative humidity equal to water activity multiple into 100. Pure water has the water activity of exactly 1. The water activity of any food is not going to be more than 1. All the food containing at least the minimum level of water, it's majorly going to be differentiate free water and bound water. Free water easily utilized by the microorganism, whereas bound water it is not possible to utilize by the microorganisms. We'll see what is the bound water and what is the free water. The free water means held inside the cell and maintaining the property of free water and it having a more mobility and it is also easily possible to remove by pressure. Bound water means is a part of molecular structure and it having reduced mobility and does not retain the property of free water. Microorganism can utilize only the free water, not the bound water, for their growth, survival, and multiplication. Each and every microorganism required minimum level of free water for their growth. Water activity is one of the important factor to determining the food safety as well as food quality. It is also influenced in the shelf life of the food product, texture of the food product, flavor and smell of the food product. Most of the bacteria does not grow in the water activity of below 0.91. In the case of molds, most of the molds is not going to be grow below the water activity of 0.8. By measuring the water activity or knowing the water activity, we can able to predict which microorganism can able to grow and which microorganism cannot able to grow in the particular food. In addition to the microbial spoilage, water activity also play an important role to determining the enzymes and vitamin present on the food material and also its impact on their color, taste and aroma. Water is made unavailable for the growth of microorganisms by using various methods. There are three major methods employed to reducing the water activity in food. The first one adding the sugar and salt, and second one adding the solidification agent, and third one water crystallization or hydrations. Adding the sugar and salt, reducing the available water or free water for the growth of microorganisms. It is also depending upon the number of moles or ion present on the solution rather than the size. For example, sodium chloride, it has the 2 ion in the solution. It is more effective to reducing the water activity or reducing the free water in the food material compared to the sucrose. And the next method is the gel formation by adding the agarose or any other solidification agent. For example, if you prepare nutrient agar, the agar concentration is 2%. If you are increasing the concentration more than 2 or 3, 4 percentage, it fully prevent the growth of microorganism in the particular media. It is also applicable for the food material. The next one is the water crystallization or hydration. Usually it prevents the growth of microorganism because it's prevent the or reducing the available water. For example, the pure water, it having the water activity of 1 at the temperature of 0 degrees Celsius, whereas the temperature reduced to minus 5 degrees Celsius, the water activity is reduced to 0.953, and whereas the temperature reduced to minus 10 degrees Celsius means the water activity is also reduced to 0.907, and temperature minus 15 degrees Celsius the water activity is 0.846, and if the temperature is minus 20 degrees Celsius the water activity is 0.823. So reducing the temperature, it is also reducing the water activity. Some of the factors that influence the water activity requirement. The first one, the kind of solutes employed to reduce the water activity in the food material. And second one, nutritional value of culture media or food material. If the food material having highly nutrition, whereas it having the low water activity, even though the microorganism possible to grow in the particular food. And most of the microorganisms have great tolerance to the low water activity at their optimal temperature. And fourth one, that is oxygen supply. If required level of oxygen is present in the particular condition, even the water activity is low also, the possibility for the growth of microorganisms. Next one is the pH. Near neutral pH, most of the microorganisms are tolerant to low water activity or lesser water activity. The last one, that is a inhibitory substance, that is an antimicrobial substance present on the particular food. It narrow down the range of available water for the growth of microorganisms. Each microorganism has maximum, optimum, minimum water requirement for their growth. If you reducing the required water level below the optimum, it will lead to lengthening the log phase of the microorganism and decreasing the rate of microbes and decreasing in the amount of cell substance synthesis. If reducing the water required below optimum, it will helpful to prevent the microbial growth or reduce the microbial growth in the particular food. The water activity of food material is determined or measured by three major methods: freezing point determination, manometric techniques, electrical device. Minimum water activity required for the growth of microorganisms. For example, most of the gram-negative bacteria required minimum water activity of 0.97 for their growth. Most of the gram-positive bacteria required minimum water activity of 0.9 for their growth. Most of the yeast required minimum water activity of 0.88 for their growth. Most of the filamentous fungi required minimum water activity of 0.8 for their growth, and halophilic bacteria required minimum water activity of 0.75 for their growth, and xerophilic fungi required minimum water activity of 0.6 for their growth, and osmophilic yeast required minimum water activity of 0.6 for their growth. If the food material has water activity below the required level, it is not spoiled or deteriorated by the specific microorganisms. Minimum water activity required for the growth of specific microorganism. For example, Staphylococcus aureus required the minimum water activity of 0.86 for their growth. Halobacterium species required minimum water activity of 0.75 for their growth. Aspergillus flavus required the minimum water activity of 0.78 for their growth. Chrysosporidium fastidium required the minimum water activity of 0.69, and Xeromyces bisporus required the minimum water activity of 0.61. Diboriomyces ansani required the minimum water activity of 0.83. Turlopsy species required the minimum water activity of 0.7 for their growth. Zygosaccharomyces bailey required the minimum water activity of 0.8. Zygosaccharomyces rossi required the minimum water activity of 0.62 for their growth. Microorganisms required the minimum water activity for their growth. Example, Camelobacter required the minimum water activity of 0.98 for their growth, and Clostridium botulinum, Shigella species, Yersinia species required the minimum water activity of 0.97 for their growth. and Escherichia coli recorded the minimum water activity of 0.95, and Salmonella species recorded the minimum water activity of 0.94, and Vibrio parahemolytica recorded the minimum water activity of 0.94, and Bacillus cereus recorded the minimum water activity of 0.93. Clostridium botulinum type A and B recorded the minimum water activity of 0.93. Clostridium perfringens recorded the minimum water activity of 0.943 and optimum water activity of 0.95 to 0.96. Listeria monocytosins recorded the minimum water activity of 0.92 for their growth. Staphylococcus aureus recorded the minimum water activity of 0.83 and optimum water activity of 0.98 and maximum water activity of 0.99 for their growth. Principal group of foods and their available water activity. Foods have the water activity between 0.98 and above or fresh meat and fish, fresh fruits and vegetables, milk and most of the beverages, canned vegetables, canned fruits in light syrup. Food have the water activity between 0.93 to 0.98 or evaporated milk, tomato paste, processed cheese, bread, canned meat, canned fruits in heavy syrup. Food have the water activity between 0.85 to 0.93 or dried beef, aged cheddar cheese, sweetened condensed milk. Food have the water activity between 0.6 to 0.85 or dried fruit, jam and jellies, nuts, some aged cheese, intermediate moisture food. Food have the water activity between below 0.6 or chocolate, honey, biscuit, potato chips, and dried eggs, milk, and vegetables. Few more example of foods versus with water activity. Example: fresh, raw fruits, vegetables, meat, and fish having the water activity of more than 0.98. Cooked meat and bread having the water activity of between 0.91 to 0.95. Cured meat and cheese having the water activity between 0.91 to 0.95. Fermented sausage having the water activity between 0.83 to 0.87. Jams having the water activity of between 0.75 to 0.8. Honeys having the water activity of 0.75. Dried cereals having the water activity of 0.65 to 0.75. Pastries fillings having the water activity of between 0.65 to 0.71. Candies having the water activity of 0.6 to 0.65. Sugars and syrups having the water activity between 0.6 to 0.75. Cake and pastries having the water activity between 0.6 to 0.9. Dried fruits having the water activity between 0.6 to 0.75. Powdered milk and dried pasta spices having the water activity between 0.2 to 0.6. Water activity helpful to control the microbial growth in the food material and helpful to formulate the profitable product and also predict the effect of temperature of use and control the chemical reaction rate and as well as moisture immigrations and avoid the caking and the clumping during the baking and new product development and also helpful to predict the packaging requirement during the storage period of food material. The specific level of water activity of food provides microbial safety, physical and chemical stability of food products. In conclusion, if food material having high water activity, example more than 0.9, it is possible to spoil by most of the bacteria. If food material having water activity of more than 0.88, it is possible to spoil by yeast. If the food material having water activity of more than 0.8, it is possible to spoil by mold. The foods those who are having the less water activity and also having a more shelf life. Based on the food material water activity, we may predict the microbial growth and preservation methods. Thank you for watching. Thank you.